Hi, I'm Arun, and my groupmates are Chua Shii, Chiu Junji, and Ahmad Fazila. We are from Home Group 1. Today, we are going to present about filter circuit design to filter out noise in ECG signal. This is the input of ECG signal. The coding here shows input coding to load the ECG signal given into MATLAB. Then, the ECG signal is sampled for 200 sampling. This 200 sampling is up to us, and we did for 200 samples. After that, the ECG signal is transformed into a Fourier transform, discrete time Fourier transform. This spectrum shows the discrete time Fourier transform of ECG signal. In other words, this is the frequency domain of ECG signal. And later on, this ECG signal is transformed to a normalized frequency. So it's also under a frequency domain, but it's under a normalized frequency. This is the coding shows to convert the ECG signal into a normalized frequency discrete time Fourier transform. Next, my groupmates will explain about the filter and which filter are best to filter out the noise in ECG signal. Thank you.
For FIR filter, our group has designed a Hamming window with number of order 330. We choose a high order filter since the transition bands will get narrower and similar with ideal filter properties as the order approaches infinity. We use a low pass filter with normalized cutoff frequency 0.4 since from the frequency spectrum of ECG2 signal, we can see that when normalized frequency exceeds 0.4, the noise will occur. The filter is designed using the Filter Designer tool and has been converted into MATLAB codes. We plotted the Z-plan of FIR filter using roots and Z-plan command. Since pole only exists at origin, this can be proven as a FIR filter. Stand command is used to determine impulse response of the FIR filter. Similar with desired impulse response, this FIR filter also gives a sync shape, which is non-causal and infinite in duration. Filter command with input filter signal and ECG2 signal will perform the process of convolution to obtain the impulse response of filter ECG2 signal. From here, we can see that there's a significant delay for filter signal using FIR filter. From spectrum of filter signal, it can be observed that the noise indicated by spike in spectrum of ECG2 has been removed.
So now I'm going to run you through the basic IIR filter design procedure. So what we did here is a dual filter with a bilinear method, and we used a second order filter and the cutoff frequency at 0.4 pi. So this line of code here will generate this graph here, and this graph represents the impulse response of the IIR filter. So next step we did a Z transform to get the poles and zero plots, and here we can see our poles and zero plots. We have two zeros at -1 and a pair of conjugates here. You can see the value here. It's 0.1848 plus minus 0.4021, and you can see here our calculations here, our manual calculations, and we got the same value. And next step, we'll convolute the two impulse response of the IIR filter and the ECG2 input signal, and we will get this filtered output signal. And as you can see, most of the noise are removed. And finally, we run the output signal using a DTFT to see if the observe the frequency spectrum and check if the frequency of noise is removed. And as you can see here, the noise at 0.5 pi is completely removed.
In conclusion, we can see that FIR filter is not good enough to remove the noise from ECG signal, while the IIR filter generates more clearer output signal compared to FIR filter, even at a low filter order. IIR filter also reserves original waveform signal, and it filters out the noise much more precise compared to FIR filter. This proved from the output spectrum. This is the output spectrum for FIR filter, and this is the output spectrum for IIR filter. In this case, IIR filter is more preferred compared to FIR filter. Thank you.